So you've got your four major components of the refrigeration cycle. You've got your compressor, your evaporator, your condenser, and your metering device. We're going to talk about all the other stuff. So we're just going to do a general overview, and then what we really want to find out from you guys, and maybe we'll send out like at mid-year kind of what you want to dig down deeper into. But we're just going to talk about some of those components that we're going to see on every system. You know, I don't want to get too rack focused or too single system focused. I really want to touch on everything that we would see on a refrigeration system and talk about specific details of those components, because there's still a lot of things that we see getting missed and a lot of things that are being misdiagnosed because there's not a good full understanding of the troubleshooting methodology behind it. So we'll run through this pretty quick. There's a lot of material here. So I will stop from time to time and give you guys a second to ask some questions as we change through the components. So devices that improve system performance are the following accessories in this one. So we're going to talk about the devices that improve the performance, and that's going to be the filter dryers, sight glasses, receivers, and accumulators. So we have credit to the Refrigeration Training Services is where we pulled a lot of this content from. So there may be variations of this depending on manufacturer and stuff of the data that we're giving you guys, but it's going to be by like a degree or two, or like when we're talking about TD across the filter dryer, it might be a degree or two or a PSI or two, but just understand like the general methodology behind it is what we're trying to cover in this class. Liquid line filter dryers. You know, we see liquid line filter dryers. I see a lot of like high temp systems that don't have minimum on the original install. I've always wondered why that is, but for the most part, medium and low temp systems are all going to have a filter dryer piped into the system. It's there to help clean up the contaminants. It's going to remain in the system. It's going to replace whenever a system is dirty or opened. This is one thing I want to talk about. We've seen a lot of quotes coming through, and a lot of quotes that I'll kick back won't have a filter dryer in it. So if we're opening up the system for any reason, and this isn't charging, or this isn't, you know, making a quick adjustment, but if we're going to open up the system and change an expansion valve or change a major component of that system, we always want to add the filter dryer in there and change it at the same time. So because you're going to introduce a lot of contaminants into that system anytime you open it. Not only, you know, are you going to have some carbon, even if you're flowing some nitrogen, you still might have some carbon from your welding, but then you're also going to have, you know, some air and moisture in that line. And what a filter dryer does is really make sure that we don't contaminate the system. And if we do, that filter, it gets held in the filter dryer. So screens and fiberglass filters remove dirt and debris. Desiccant removes moisture and acid. So we're going to talk about the specific types of filter dryers we use, especially like in the supermarket applications, and why. So here's a cutaway of the Sporlan. You know, I'm not going to tell you which one to use, but my personal preference is the catch-all Sporlan brand, just because you'll see the way it's constructed as we go through this, and I really like the way that they've built their filter dryers. So you've got the refrigerant flow always goes a specific way. The arrows will be on the outside of that canister to tell you which way that refrigerant will flow. So you've got the desiccant core inside of there. So in the fiberglass screen that kind of picks up the bigger particles. So let's talk about that identification of that filter dryer. So whenever you guys are dealing, no matter which brand you're dealing in, it's going to have an identification number on there. It's very significant on filter dryers. That C really is for Sporlans. So EK or extra clean is for Emerson. Used to be Alco for you older guys. Numbering systems is standard. The first two numbers are the cubic inches. So I have seen guys use filter dryers as like in smaller systems to hold a little bit more charge of the refrigerant system for the metering device to make sure we're getting liquid there. There's nothing wrong with that. Just understand when you're charging and you add a larger dryer, you need to adjust your charge to the larger dryer. And there's a grid on the back side of that box that will tell you if you go from like a 3 cubic inch to a 16 cubic inch or an 8 cubic inch, that the charge adjustments that you need to do for that. So the last number is going to be your connection size. So, you know, if you're dealing with a 163, that's a 16 cubic inch, 3/8. So if you're doing a 164, that's 4/8, which is ½ inch, so and so on. So anytime you're looking at that, you know what connection size you have and what the cubic inch capacity is for that size of the dryer. So whenever you guys are doing dryer change outs, make sure you always, you know, if you have one on your truck, always size up. Don't ever size down. Meaning if you have like an 083 on there, and you have 163 on your truck, again, swap it out with a 163, but then just adjust the charge accordingly. Don't go the other way. Don't go from an 8 cubic inch down to a 3 cubic inch. That's never good for the system. So here's a picture of the outside. So again, you have your directional arrows. You know, your C is your classification for catch-all. There's your 16 cubic inch, 3/8 connection size. The S on the end means sweat. So that's going to be a sweat filter dryer, 163. So that's how all Sportlands have been marked for years and years and years. And it's the same thing with Danfoss or Emerson. So there's kind of the breakdown of what we just talked about. So is there any questions on this so far? So we don't use, I don't personally use a lot of Danfoss. Maybe some of you do, but it's the same thing. So you've got your DCL, Danfoss is a manufacturer. So same thing, you got your cubic inches, you got your connection size, and you've got your sweat classification. So HFC, HCFC, or CFC, so this includes 410A, so this is for, you know, high temp application. And then it gives you your max working pressure of 610 PSIG. So, I mean, anything you're getting off the shelf should be usable for any of the refrigerants that we're using. So just keep that in mind. If you're pulling something out of the shops and it's fairly old, just make sure that if you're going into like a 410A system, that you have the max working pressure set to where it needs to, just so you don't scatter the contents of the filter dryer. So types of desiccants, you got activated alumina. So this is for the high acid, moderate moisture capacity. If you guys come up on, so a couple things on the dryers, when you guys are doing filter dryer change outs and you run into an HH situation, a high acid situation, and if you're dealing with the cores, the 4864 cores, or you're dealing with a smaller system and you test positive for acid, or you pull that compressor out and there's a burnout, make sure that you put a high acid dryer in there. Do not leave a high acid dryer in play. So what you want to do is you want to run that high acid dryer in that system for 3 or 4 days, you know, and then come and test again, and then swap them out again if you need to, and then run it for a couple more days and then test the system again. You're going to be testing the oil for acid. So just get one of those phase 3 oil tests and test that oil. So if there's still question there, once you've got it to where you're not testing positive for acid, then you're going to want to pull that filter dryer out of there, and you're going to want to replace it with a regular filter dryer. So once that's done, you know, you should be good. So anytime you're trying to remove moisture or acid from a system, you're really going to want to, you know, make sure that you change that to a high acid dryer, and then always go back, always go back in with a regular dryer. So, because that's going to be your permanent fix, is that regular dryer. So any questions there on burnout or water situations? Okay. So here's the inside and how it flows through. So you've got your solid desiccant core. Like I said, this is going to be Sportland's construction. You've got that shock-proof assembly, so it kind of holds that core into place. You're going to have the fiberglass pad for your 100 mesh screen, and then your outlet strainer. So, and that's the flow. Does anybody know off the top of their head the pressure drop across the dryer before you condemn it for Sportland?
Is it 3?
3 is actually high. I mean, you're close. It's 2. So yeah, 2 PSI. So at 3 degrees temperature, if you've got clamps and you can tell, the hard thing about clamping temperatures is sometimes you get the ambient air kind of mix around that. So you got to make sure you're getting a good pipe test. But the best way to do it is if you have a pressure tap on each side of that, and you get a 2 PSI pressure drop across it. So you better make sure your gauges are calibrated. You're going to want to see that. That's what Sportland recommends. Obviously, if you're getting a 3, then you know. But, you know, if you're getting a 2 or 3 pound pressure drop across that dryer, just change it out. If you're close, just change it out anyways. Like we say with filter dryers, when in doubt, change it out. Just get rid of it and get a new one in there. The other thing too, guys, is like, I know I very, very rarely see it anymore, and I know it's a pain in the butt, but the worst thing about when you're changing components and you change a dryer, you don't flow nitrogen. You just introduce carbon on the inside of that line of a brand new dryer. So anytime that you can flow nitrogen, try to flow nitrogen. So if you guys don't have the components to flow nitrogen is just great practice. It's a kind of a lost practice because I know it's inconvenient, but it's still best practice. So liquid line filter dryer for Alco. And so in this construction, you kind of see why I prefer Sporlan over the Emerson. It's just, I like the way that they're constructed inside a lot better. So you got fiberglass pads on both sides. You still got your 100 mesh screen and you still got your end strainers, but you have strainers on both sides instead of just the back side of that dryer. So choosing the correct filter dryer. First, determine the tonnage. So obviously AC is different than refrigeration, and then pipe size and connections. If you guys are doing a design build, and you don't know what to do, you can contact your local parts house and they'll help you with that sizing, or I'm more than happy to help you. There's a couple guys around that can help you with the sizing of that dryer. Most of the time in the service side, you're swapping out. So like I said, if you're ever changing out a filter dryer, always go up in size, never go down. So, and that'll keep you safe. So, and then, like I said, adjust the charge accordingly for that. If you have a receiver in there, you might not have to adjust the charge, but if you're dealing with a sealed system critical charge with no receiver, then you're going to need to make sure you adjust the charge accordingly. Refrigeration system components, suction line filter dryers. So let's talk about suction filter dryers. So the purpose for suction filters is usually on startup, or usually when a major component's changed out and they're trying to clean the system, they'll throw a suction filter dryer in there. Suction filter dryers are meant to be temporary. So it's in the suction line. It removes debris, moisture, and acid from the system. It's designed for temporary use to clean up the system. Always install after a compressor burnout. So, and then always, usually, on the sweat-in kind, there's going to be pressure taps on both sides. On the larger shell kind that you have, you're going to take it off your suction king valve and the Schrader port on the suction filter itself. That'll be the difference between your pressure drop. So excessive pressure drop is equivalent to 3 degrees temperature drop. So you're going to take that pressure drop, you're going to convert it to temperature. If you have 3 degrees, it's time to take those out. So usually they'll leave them in for a couple weeks on startup. And usually that's in the scope of work, and then they'll pull those. So I have had a couple situations where some have gotten missed, and we found that the restriction was at the suction filter. So again, just verify that those have been pulled, and that, if you ever have a major burnout system on a rack, or you're doing a big change out on a system, you want to throw those back in temporarily for a few weeks, let it clean up the system, and then go back, make a scheduled appointment and go back and pull those out. So here's a picture of the sweat-in style. Like you can see the pressure taps on both sides to be able to test across that to make sure that you're not restricting. There's your shell style. So, and there's the cores, a cutaway with the cores inside. So again, you've got your Schrader valves, check the pressure drop across that suction filter. Again, this is a temporary filter that you throw in there. You can see on the Sporlan, the construction is very similar to the liquid line filter dryer, but the components inside it are a little bit different. So let's talk about sight glasses. So location on the liquid line. Do we put the sight glass before or after the filter dryer? It's kind of gives it away here on the picture, but we always do it after the filter dryer. So what do we want to see in the sight glass? So
Smooth flow.
Clear full, right? I hear clear, and then the first thing I ask a guy when it calls me on the is clear full or clear empty. So Well, and a couple times you come up on bigger systems with sight glasses and it looks full, but if you shine your light down in it, you can see a river flowing down in the very bottom of the sight glass. So the biggest thing that we need to understand about sight glasses, guys, is, now we're dealing with 5 and 6 component refrigerants. And with 5 and 6 component refrigerants, you're going to get some bubbles. So we want to make sure, like, what the sight glass is there to serve a purpose is that we're sending a solid column of liquid to the expansion valve. So, and the way that we're going to be doing that is, making sure that we're clear full, that we have the proper charge on there. If I'm flashing on a sight glass, what's the first? And I want to know if I'm low or if I'm not condensing. What's the first thing I'm going to do? We've covered this in prior years. What's the easiest check I can do to make sure that I'm not over?
Check your pressures.
Just grab the line. So how's that liquid line going to fill the sight glass if it's not condensing? It's going to be hot.
Hotter.
Yeah. So what your liquid line should always fill at is a little bit warmer than ambient. So the easy check to know if you're undercharged or overcharged. If you're undercharged, it's usually going to be cool. So a little bit cooler. If you're not condensing and you're not rejecting that heat and it's flashing and you got flash gas going through there, then you're going to grab that line. It's going to be significantly hot. So, and it's not going to feel like it's condensing. So the quickest way to check when you're flashing is to just grab it with your bare hand and see what the temperature of that liquid line feels like. That's going to tell you a lot. So, I mean, you can get into gauging up and stuff, and that's to do some verification checks. But the quickest, easiest way on a small system or even a larger system is to start touching those lines and see what's going on. So the dot moisture indicator, it's really just a piece of paper that actually picks up the moisture. If you do have moisture in the system, so we want to see dry system, we want to see that green. If you do show a yellow, you might turn it yellow when you're doing some work on it. Give it about a day is what they tell you in the manufacturer specs, and it should turn back to green. So if you're doing some work and you're trying to get non-condensables or contaminants out of the system, and you do have a yellow sight glass, you want to make sure that when you do come back to do your change-outs and stuff, that you're turning that back green. So if you cannot see through the sight glass because it's old, just change it. So next time you pump it down to change your filter dryers, let's change the sight glass too. Sight glasses are a very, very good tool in a lot of systems for us to know what the liquid is doing, make sure that we've got a solid column of it, and then to make sure that, that it's not coming and going. So the nice thing about seeing that is just like, you guys have seen this, all that you guys that have worked on Costco racks, but you'll see that liquid leave and come back and leave and come back. So depending on when those large systems go into defrost or when the coil's going into split and unsplit. So it's good to understand what that's doing so that when you do run into an actual load charge situation, you're making the right call. So causes of bubbles, lack of refrigerant, low load, restriction. So restriction is going to be when it doesn't condense. And so, and again, you guys, with your 448s, I think 448 has 5. I think it has 6 different components in the new 448 refrigerant. So from what I was looking at, so when you're dealing with that many components in these blends now, you're going to get some bubbling across that. So we just want to make sure that we're making the right diagnosis there. So receivers, the location of the receiver is in the liquid line after the condenser. So the purpose is store tank for liquid refrigerant. Capacity, the full charge of a system plus 20. In other words, the full charge will only take up 80% of the receiver. So valved on a system with the expansion valves. So let's talk about receivers real quick, kind of from a field troubleshooting. So when we're snap torching those receivers, should we see them more full or more empty this time of year?
Full.
So it depends. So that's kind of a trick question. What the thing about it is like if you're dealing with an indoor unit, yeah, it's going to be pretty. They're going to want to stack there. If you're dealing with an outside unit where the condensing unit is outside, like on a remote system, a walk-in cooler, or you're actually going to be more empty because the refrigerant is going to be where?
In the condenser.
Yep, it's going to be stacking in those condensers. So it's a good point of discussion today. As you guys go out today and you get called out for your refrigeration calls, there's going to be a lot of gas out of the systems in the next few days with these really cold temperatures. The reason for that being is any repairs that we made during the summer stuff, we put in enough charge that we thought was adequate for the time of year. Now that refrigerant is starting to stack because of the head pressure control valves. So it's stacking in those condensers, whether it's a headmaster on a smaller system or it's a holdback valve on a larger system. Those regulating valves are actually stacking the condensers. So to eliminate the condensing capacity. So what happens here is those valves hold back refrigerant to take, if you have a 10-ton condenser, they're going to fill liquid into that condenser halfway through it to turn it into a 5-ton condenser. And what that's going to do is help keep that head pressure up. The reason why we want to keep that head pressure up is because we need, over 100-pound pressure drop across the expansion valve to push that pressure through that expansion valve to boil off inside of the evaporator. So that's why we have to maintain that head pressure. So the refrigerant is going to want to migrate to the condenser. So you're not going to see it in your receiver. It's going to be staying in that condenser because of the valves between the condenser and receiver. So just understand, it's okay to add gas today. Just be real thoughtful about how you're doing that, because we can very much add too much and then we're taking it out in the summer. So, but we will be stacking gas for the next few days. We usually have our busiest day when we hit our teens and our single digit cold snaps. We're usually out adding gas in the refrigeration side of it because we don't have enough to stack in the condenser to eliminate that capacity to keep our head pressure up. Does that make sense?
Yeah, it's when you seem to find leaks on things more too.
Yeah, I mean, this, in the fall, spring, and winter, it's funny because refrigeration stays pretty consistent because of the head pressure controls and because of the the stacking that happens in the colder climates. So we should be seeing that. I know I've seen the call volumes; they've gone up quite a bit. So, and they're going to continue to rise as we have these these really cold days, because that refrigerant's going to want to stay on the roof instead of get down to the case. And those valves are going to continue to hold back to keep that pressure up. And so we're going to need to have more refrigerant in the systems to be able to flow through the system like it should. So one thing on this style, guys, like right here, can you guys see my cursor on the screen?
Yep.
So right here, there's a soft plug in these receivers. So this is a common leak. So anytime that the system goes under an extreme amount of pressure, so they're required to have some kind of soft plug or pop-off mechanism in all receivers so you don't create a bomb. So you guys need to understand, when you're doing your leak checks, make sure that you're leak checking that area of the receiver there, because usually it's just a sweat connection up into this area. And there's some receivers that have it on the top of the receiver, but somewhere on that receiver, they welded in a soft plug for an overpressure situation. It's required when they build these things. So the liquid comes in from the condenser, collects in the cylinder, so forces up the dip tube, and then goes into your liquid king valve to the TEV, the thermostatic expansion valve, or the metering device, depending on what you're dealing with. Usually it's always going to be a TXV or a TEV or an EEV, electronic expansion. So, and the reason why we need to have some fudge factor there, I call this, the extra liquid in the system, is because that TXV is always throttling back and forth. And so what it requires on the inlet side of that is that solid column of liquid. So, and if it's throttling at a massive rate, like say you're coming out of a defrost, or, you have the system down and you're bringing it back online and that thing throttles wide open. Well, if we didn't have a receiver on there, then it would be starving on the one side of it. So, and it would cause it not to create enough superheat or boil off enough refrigerant or flood the coil enough to adequately to get the heat transfer you need for the sizing. So we have to put these receivers in there to make sure that we keep that liquid on the backside of that expansion valve. So the other thing too is, has anybody not snap torched a receiver? Do you guys want me to go over that? Has anybody never heard of that? It's a pretty common.
Yeah, Jim, can you go over that?
Yeah. So let's talk about it. While we're looking at this cut out of the receiver, you see your inlet and you see your outlet. Okay. When you guys snap towards the receiver, you see this. So, you've got if you're looking at it like a clock, and you've got your inlet at 9 o'clock, and you got your outlet between 12 and 1 o'clock. Where I want you guys to snap towards this style receiver is at the 5 or 6 o'clock area. So on the opposite side of where the refrigerant's coming in and going out. So because you're going to get different readings. And so what you're going to want to do is you're going to want to take your snap torch, and you're going to want to light it up, and you're going to want to run it up and down the side of that receiver, okay? And then you're going to want to very gently touch the side of it. And what will happen is refrigerant won't allow the sidewall of that receiver to get hot if it's got liquid there. So what you'll be doing is you're boiling off the refrigerant inside. So what you want to do is run your fingers up it until you feel it get warm or hot. So, and then two fingers below where it's getting hot is about where your liquid level is. It's not an exact measurement, but it's very close to testing your receiver level. Does that make sense?
Yeah.
And where exactly should that be? Is it halfway or is it 3/4?
It depends on the time of year. So I like to see, like, in the warmer months, you're going to have more refrigerant in your receiver, just because you don't need it. You're pushing a lot and your valve's throttling. In the winter months, you're actually going to have less in your receiver and more in your condenser. So because you're stacking more in your condenser, and usually your holdback, your headmaster is right there on the inlet side of that liquid, you're going to be stacking more back in your condenser, and so you're going to actually have less when you snap towards your receiver. I like to see it about 30 to 40% full in the wintertime and 60 to 70% full in the summertime. Does that make sense?
Yep.
So you haven't lost any refrigerant. You're just using that refrigerant to eliminate some of the capacity in that condenser. So the one thing you don't want to do is like maintain the same level year round, because depending on what your valves are doing, you want to make sure that you're holding a good charge. So a couple things is, like, don't just go off your snap torch level. Look at your sight glass. Make sure you're condensing properly. Feel your return bends. So at no point have I said gauge up to the system. You can do all these things without ever breaking the seal of the system. I'm not anti-gauge up, but it's the very, very last thing I like to do, because anytime we introduce our hoses to the system, we have a potential of introducing contaminants into the system. So I do not like to gauge up to things unless it's last resort or I'm making the repair. So if I need to gauge up to do some calibration, then I will. But mostly I want to be able to use my meters and my hands, and my senses. So the king valve and the receiver location. So let's just talk about king valves in general. So because king valves, we're going to go over this a little bit. I really want to, we all know what a receiver does, but there's a difference between angle valves or, ball valves and king valves. So you're going to see king valves on your discharge and your suction line of your semi-hermetic compressors. You're going to see it on, a lot of times on even your hermetic compressors on the suction side. Usually they don't have a valve on the discharge side of that. So you just want to make sure that we understand, like, how, when we're gauged up, what position is what. So when you're talking to some of us guys on the phone, the difference between, front seated, back seated, and then partially seated. So, and we'll go through that. So we've talked about this too, guys. Please never, never, never put a pair of channels on that valve stem. And please don't use a crescent wrench either. Make sure you buy there's two sizes of service valve wrenches that you can buy. The bigger ones for the rack systems, and then there's one general one that does 90% of your smaller systems. Make sure that that's part of your arsenal of tools, that you're not using. I've seen guys and they'll look at me right before they go for their Leatherman and I'm just like, don't do it. So don't put teeth marks on those valve stems. So, and the other thing too is right here, if you guys are looking at my cursor, there's usually a packing nut. Some of these are packless, but on some of the bigger king valves, there's a packing nut there. If you have a leak there, just gently tighten it. So you don't need to get on it super hard. So we're talking about brass components. It's soft metals. So you just want to snug it up until it stops leaking. If you get on it too hard, you're going to damage the valve. The other thing too is I've watched guys front seat and back seat, and when they do, they give it a really, really hard turn at the very end, thinking that that's going to do it. What guys are doing is you're bending the seat inside there. So you just need to gently back it off and give it a little snug, just a little finesse. You don't need to get on it like McGill or Gorilla and really get after that thing. I watch guys get on these valve stems way too hard, and you're damaging those valves. So you got your liquid from the condensing, you got your dip tube in your receiver, and you go up. So the position of this valve, king valve right now, is fully back seated. So the top part of that valve is the seat, and then you've got your stem, and then you've got your packing. So this is showing a packless valve, but that's that little brass piece that you can put a crescent wrench on and tighten up that packing. So if you gauge up to it, then we're going to crack the valve. So, and that's what that does is it doesn't seal the system. So now we're still seeing the pressure of the system open and functioning, but we actually can gauge up and see the pressures of what that running system's doing. So, and then if we want to front seat it to isolate it or pump down, or this is where if we were going to change the filter dryer, this is where we would shut it off. We would pump it down back through the system, and then we would hold it in the condenser and receiver, and then we would shut off the suction line to isolate, and then we would make our repairs between the liquid king valve and the suction king valve. So, and then we back seat it. So if we tell you guys to front seat it, that's always going to be a clockwise turn to run it all the way in. If we tell you to back seat it, that's going to be back seated counterclockwise all the way. If we tell you to crack the valve to take pressure tests, make sure you gauge up to it first, zero out your gauge as always for altitude. And then you're going to turn that valve stem a quarter to a half turn, depending on how damaged the valve is. But you should only, if it's a good valve, you should only need to turn that a quarter to 2/3 turn, and you're going to be able to get a pressure reading off that king valve. So purge hoses, de minimis. So, or get your low loss fittings. Suction line accumulators. Okay, so let's talk about suction line accumulators, because I see this being a need that we're finding. Anytime you guys have more space or volume in your evaporators than you do in your condensing unit, as far as tonnage, we need to put suction line accumulators, or we need to size with suction line accumulators. We have a lot of Mavericks and such that we're running like a 4-degree superheat. Well, if we're running a 4-degree superheat, we're flooding the coil. Okay, and if we're flooding the coil, it's always good practice to try and get a condensing unit with an accumulator, because what you're going to do there is you're still going to get the superheat you need to your compressor, but you're not going to knock the oil out or flood that coil or flood that compressor. So when you're running that low of superheat, you're running flooded situations, you always want to see an accumulator. You're going to see accumulators on heat pump systems. You're going to see accumulators on large freezers. And the reason for that being is it's just like, that's kind of like a fudge factor component, to where if you have more, if in your off cycle, or if you're shutting down the system in defrost and you're not pumping it down, then that coil is going to have a lot of liquid refrigerant inside it when it comes out of defrost. And what that does is when that valve opens up, that suction valve opens up out of defrost, and it starts flowing refrigerant again, there's going to be quite a bit of liquid coming from the evaporators to the rack or to the single system. And what that does is it's eventually going to knock the oil out if you don't have an accumulator. So if you're losing compressors, but your superheat's set right and you're doing everything you can, then you need to maybe size for an accumulator in that system. And we've done that before. I've done that on a few larger systems where we had lost multiple compressors at an Asian market and stuff, and we actually put an accumulator in, and that took care of the problem. So refrigerant enters, liquid falls to the bottom, and then it boils off in the accumulator. Do not insulate an accumulator. So I've seen guys actually try to insulate an accumulator because it's frosting and rusting. You don't want to do that. So accumulators use the ambient heat around it to boil off that refrigerant. So that heat transferring through that accumulator to boil that off. So if you have an accumulator in this time of year that's an ice ball, you're going to want to get the ice off as well, because again, ice is an insulator. If you're dealing with a freezer and you have ice around it, now you're not protecting the compressor. So you want to make sure, if you guys come up on a service call and you have an accumulator that's iced up and it's got 2 inches of ice on it, you're going to want to shut that down and knock that off. Or melt it off. Go ahead.
What's causing it to ball up in ice? Is it too much refrigerant in it or what?
No, it's an outdoor unit. Yeah, it's too much refrigerant. So they're there for a reason. I mean, if they're icing up or frosting, that's normal. They're supposed to do that. So because, right, as you can see, anytime refrigerant boils, it's going to frost. And so as that refrigerant boils, it's going to frost the outside. If it's really cold outside and it doesn't get hot for a couple months, like we see this a lot of times on smaller systems up north, is it never gets above freezing for weeks at a time. And so you'll walk up on a store, and what do you know, the compressor's off on thermal, or the valves are damaged. And if you look at the accumulator, it's got 3 inches of ice around it.
Yeah.
So we want to make sure that might have been part of the problem. So you want to make sure, like in those colder climates, Idaho, Utah, Denver, Colorado Springs, those areas, that we make sure that anytime that we have the opportunity, we get on a service call and you do see ice on that accumulator, take the time just to get that clear, either melt it off or take some time and get that, because all you're going to do is have another service call there in the future. Especially with these cold temperatures that we're seeing already, we might have some floodback issues with our systems, because these things are going to start icing up.
Okay, because I did that one time. I knocked it off and put it back in service, and that thing immediately started to freeze all the way up that accumulator. So
yeah,
dragging some of the Freon out a little bit.
Yeah, and again, it may be a calibration issue. So if you're frosting all the way to the top of that thing and you're doing it right out of the gate, you might do that right at first, because remember, when you first start up a system, that TXV is in what position? It's throttled all the way open.
Right.
So because it's trying to hit it, it's trying to get down to its set point. So when you might get an excessive frost out of the gate because that valve's wide open, you're shooting straight liquid through that valve. It's very saturated. It's boiling off at a massive rate, but it may be very saturated. So you might see excessive frost. Get that case down to the optimal temperature you need to, of what it should be, and then watch what it does. If you're still excessively frosting, you might need to go after that expansion valve and calibrate the superheat. But do not as always, never make that adjustment until you're, within, 4 to 6 degrees of operating temperature.
Okay.
Yeah, Jim, I think Dedrick's talking about is we had a 0-zone 2-door freezer when we took care of 7-Elevens, and it was icing up in the middle of summertime. And we found that it was the heat exchanger in the bottom that was actually restricting.
It was cracked, and it was flooding liquid right into the suction line.
Correct.
Yep. And so that's what I'm saying, guys, is like once you get it to optimal temperature, what you should see is frost at the bottom, and then it should start boiling up, about a third to midway up. If you're getting more excessive than that, then when it gets colder or when the ice doesn't melt off that thing, all you're going to do is knock the oil out of that compressor and then try to compress liquid and take the valves out. So what you really want to do is that's how you determine if the accumulator is sized correctly. So we don't run into accumulators every day. And so a lot of guys are confused about how the frost pattern should look, or when you use one, or what it should be doing. What I would say is if it's a third to halfway frosting up, but then it's coming off in defrost, then it's doing its job. If you're going, past the halfway mark all the time, then we have a bigger problem. So you got too much liquid coming back. You're flirting with it. It's gonna eventually creep up to the compressor, and then it's going to knock that compressor out. So like you said, you found a cracked heat exchanger in that one. We've seen that twice on those 0-zone cases, just in the last year. So, and we have heat exchangers on here, so we'll talk about that when we get to that. But yeah, if you have an excessive flooding problem, always go after what's downstream. It's not, boiling off the liquid soon enough, because remember, we want to hit that superheat at the evaporator. That's telling us how much heat transfer is happening at the evaporator. But then the superheat at your compressor, you still want to take that, because that's going to tell you how much liquid is still coming back to your compressor. And if you're dropping below 20 PSI on superheat, 20 degrees superheat on your at your compressor, it's coming back too rich. Now, I know every rat guy on this PowerPoint is saying, wait, we can go below 20. Yes, on a rack, when you have multiple compressors and a big suction header, that is correct. But for single systems and for most of the systems out there, if you're getting close to 20, you're flirting with it. Any other questions? So, other thing the accumulator does is help with the oil return. So, and that's what this is showing. Moving on. So, devices that improve system performance and follow accessories are oil separators, heat exchangers, vibration absorbers, and crankcase heaters. So, where and why have oil separators? So, where we're going to see oil separator, guys, mostly is on rack systems. So, the location is on the discharge line, close to the crankcase heater, in a warm location. So, you do want to make sure that you're getting it, you know, if you're dealing with certain, like the turbosheds and stuff, and you're dealing in low ambient conditions, high pressure oil separators, you want to make sure that oil separator is, because separation happens right there and storage happens of that oil. We want to make sure that we are nice and warm. I've had many situations with like on the Husband Super Plus racks where it's in the machine room is, you know, is open to the outside. Even though it's inside, it gets really cold there. Therefore, the separator gets cold, and then it starts bringing liquid through the oil separator into the compressors and knocks the compressors out. So I've blown a couple head gaskets on some systems with that in that situation. So just make sure that your oil separator is nice and warm. Anywhere that your oil is touching on your rack systems, you guys should always be touching the separator, touching the oil lines, and then touching the oil pump on the front of the compressor. It should always be warm. Anytime you're getting cold there, you got liquid in your oil, that's a bad thing. You don't want that stuff to be cool or cold at all. So oil separators, for you rack guys that are on here. So where we usually see a problem with these is this float gets really gummed up with debris and filings. So we usually have to drop the bottom plate out of those low pressure oil float systems and clean this float right here. And it's attached to the bottom plate. Or what we've seen on now 3 times in the past 5 years is this screen right here comes detached inside, and it actually comes down and pins the float down. So, or pins it to where it won't open. And so what happens is like this thing will just keep passing oil and refrigerant through the system. So you'll go to pull this cap off and it'll be empty, and you'll be like, oh, well, we don't have any oil. So add a gallon of oil. So, and what happens is this float needs to open when that float is and push that oil up, or it just keeps passing through the system. So you may not think you have oil when you drop this, and, you know, it's because it just keeps going downstream. So when that oil flow gets pinned by this screen, so what you want to do is anytime you're dealing with an oil separator, you want to be able to drop that plate, and you actually want to physically reach up inside there and try to grab that screen and move it with your hand. If it moves, you got a problem. That thing should be welded in and not moving. So it's stumped some of my best people. So just understand that, you know, when you guys are dealing with oil separators, if you have any questions on that, give us a call. So we've seen some stuff on this, but that's usually what happens with these separators is that screen becomes detached, or this float gets gummed up. So the first thing you want to do is pump down the discharge line and the oil lines, go after the float, clean the float. And while you have it open and you're cleaning the float, I want you to reach up there and check that screen. That's what's being missed, is guys aren't reaching up and making sure that the screen is stationary and it's not moving. So there's your graphic. So it separates the oil from the discharge. The high pressure pushes down. When the float opens, that high pressure pushes down on the oil, sends it up through the tube, and then sends it actually to a float, not directly to the compressor. So, and then the discharge gas keeps moving downstream to the condenser. So as you can see in this graphic right here on your oil separator, you see that oil flow. Anytime you're dealing with a separator, you're going to deal with an oil flow. What the flow does is determine how much oil will allow into the compressor at any given time. So when there is an adjustment on this flow, what I would suggest is, like, we don't make a habit of adjusting those. They very rarely need adjustment, and most of the time when we adjust them, we end up changing them. So usually once you set it, they work or they don't. So how it operates. Suction line absorbs heat from the liquid line. So benefits: subcools liquid, prevents flashing from entering the TEV. Important on long liquid line runs, improves evaporator efficiency. So you guys, anytime we're using heat exchangers or subcoolers, we deal with it in supermarket as mechanical subcooling. So what we're going to do is anytime that we can subcool that liquid before it hits the expansion valve, we're going to get more heat absorption property out of it when it's going through the coil. So we're going to be able to exchange more heat, per foot, per cubic foot of gas, per pound of gas that we send through that evaporator. So here's the inside of a heat exchanger, kind of what you were talking about, Tom. You've got your suction line, suction pressure that runs through the middle of it. It's got an outside section where the liquid line goes through around the suction line. So the suction vapor absorbs added heat from the liquid and then sends it right to the expansion valve. Usually when you're dealing with an inline, it's fairly close to the metering device. So, and it's usually inside the cooler. The one thing I will tell you about, anytime you're dealing with, liquid lines and long runs, you're going to be dealing with adiabatic expansion, which comes from all the heat around the copper line, is going to cause that refrigerant to want to start to boil as it goes out to the case. So when you're dealing with long runs, always make sure the integrity of your insulation is good. And then when you guys are dealing with these types of things, what happens, these types of heat exchangers, is a lot of times this inner wall will crack because it's ribbed, from heat and cool, and it'll start dumping liquid directly because liquid is the higher pressure of the two. It'll start dumping liquid refrigerant right into the suction line and sending it directly back to the compressor. So right here is a picture of that. Like I said, pretty close to the metering device and inside the cooler. So vibration absorbers. The one thing I will tell you about vibration absorbers is they need to run parallel with the crankshaft. You can never run perpendicular with the crankshaft. You will break that thing in a matter of hours. So you always want to run it parallel with the direction of the crankshaft on the compressor. Any questions on that? I've actually seen 2 applications where on the rise they put the vibration absorber. And sure enough, I was out there changing it out and repiping it because it had dumped the whole charge. So vibration absorbers or vibration eliminators protect tubing from vibration and leaks, used on semi-hermetic compressors, near compressors, on suction and discharge lines, and in line or parallel with compressor crankshaft. So that's the inside of one. Looks a lot like a heat exchanger on the inside, but it's bent copper. It's ribbed copper so that it can take that vibration. So with it being copper, obviously, if you're putting an excessive amount of vibration on it, it's going to harden the copper, and then it's going to break the copper, and you're going to have a leak. So luckily, I don't see a ton of this anymore, of this type of application. It's usually in the older systems. So everything's rigid mount now, so in rigid pipe. So that's the importance of when you guys are dealing with parallels and stuff. Make sure you're checking your rotations on your compressors. They should all be the same. We found a lot of it where we've had a lot big rack leaks on discharge lines and stuff, where 2 or 3 of the compressors had been wired backwards and they were running opposite on rotations, which causes an insane amount of harmonics on the rack. So crankcase heaters, it's a good topic for today. So with it being cold outside, is under or around the compressor crankcase. How many of you guys, when you guys do your checks at any given time in the cooler months, check the amp draw on your crankcase heaters? So, if I challenge you guys to do anything for the next few months, let's make sure that anytime we're working on these outdoor units that we throw an amp clamp around those heaters. And, you should see those things either running all the time or in the off cycle. So depending on the application and the type of unit. So some of them are wired directly into the top side of the contactor. So, or they should be running in the off cycle. So when that compressor shuts off, crankcase heater's on. So, and it's boiling that refrigerant off in that crankcase. So to prevent a flooded start. Is anybody doing that? Is everybody doing that? So does everybody understand the purpose and importance of a crankcase heater? So I kid you not, I'm not going to tell what market it is because we might have some guys from that market, but it was a warmer climate area. And I was out walking the Maverick stores, and I went to 4 stores, and I only had 2 crankcase heaters working of all the equipment in all the locations. So it was like 26 crankcase heaters that were burned up. I mean, they were older stores, but it's super important we have those things working. So that refrigerant is going to migrate in the off cycle, especially if the unit's outside into the crankcase. It's super important that we have that crankcase heater working. So if you're dealing with an indoor rack room, and the rack room is, you know, temperature controlled and it's nice and warm, it's not necessary. So you'll see a lot of racks without crankcase heaters working or even in there. And it's because, you know, that rack room is probably always maintaining 70 to 80 degrees. And that's why they don't think it's necessary. I think it's always good to have crankcase heaters in play, just because it doesn't matter what the ambient is, you're still going to have migration happening with the off cycle. The other thing too about racks is they're not supposed to run static. And so they're always moving refrigerant through the system. So it creates a situation where the suction group isn't allowed to have migration take place. So a couple different tiles. You got the coil type that's bolted onto the bottom. So you got your plate type also bolted onto the bottom, and then you've got your insertion type. So this is usually what we see in a lot of the bigger compressors. So semi-hermetic compressors, internal and plate heaters, hermetic compressors. You see the strap heaters. Does anybody carry or stock crankcase heaters on their trucks anymore? Like the zip tie, the black zip tie kind, or this metal kind with the worm drive?
I don't have one, no.
Yeah, so I mean, it's good practice sometimes to have. I used to stock a 120 and a 230 of the zip tie kind. It kind of, you could put around the semi-hermetics. So I always had those on my truck. So I don't see a lot of guys stocking them now. I don't think that they see the importance of it, but a lot of our compressor fail or flooding is going to happen this time of year because the crankcase heater's not working. So, you know, like I said, if we can take anything away from that, let's make sure that we're checking those. Any other questions, guys? So we kind of touched on a lot of different components and a lot of different material on those components. So mostly it's just, hopefully you guys understand how to snap torch a receiver, what an accumulator does, and we need to check our crankcase heaters. So there's the 3 takeaways I would take away from this class if I had a choice. No questions? You guys are easy.
Thanks, Jim.
Thanks, guys. Have a good day.
Thanks, Jim.
Take care. Stay warm out there, guys. It's going to be cold.